Let's recap really quick what we did in the last video. We wrote an extension on string that lets us take a string containing reserved characters and percent encode it. That was the easy bit. We then created an encode function right here that takes a parameters dictionary and returns a percent encoded string in the format key equals value, and with each key value pair separated by an ampersand, right there. The main part of this method is the query components function that encodes the value and returns it with a key. Now we called this earlier without actually having defined a function. Query components takes as a key a string and a value as an any type. It then encodes the value as a string and returns the key value pair in an array of 2-element tuples. So in here, we start by creating an array to hold our return type. So we'll say var components equal, and this is an array containing a tuple, and each tuple has 2 strings. The body of this method is slightly complicated, only because we don't know what type of value will be passed as a value. Think of a JSON response that we've worked with in the past. By using any particular key, the value can be a type like string, int, or double, and that's easy. Or it can be more complicated where the value itself is a dictionary or an array. Parameter values can be represented in one of these 3 formats, so we need to account for all cases when building our URLs. In the first case, we'll assume that the value passed in here is a dictionary itself. So we'll say if let dictionary equal value as string to any. The body for this case will be almost the same as the body of the encode function. So here we're going to iterate over the dictionary first and get a key and value. So we'll say for nested key, because now value is a dictionary, so it has its own keys. So for nested key and value in dictionary, we're going to now call the query components function again on this key value pair. Except this time, instead of just using the nested key as an argument for the key parameter, we're going to construct a string that contains both the key from the outer dictionary, so this key right here, and the nested key from the inner dictionary. Now, this is not something I'm just doing for fun. This follows a standard format of encoding values as dictionaries in a query string. So I'll say let nested components equal query components with key. And for the key, first, let me just leave an empty string in there. For the value, I'll say value. And for the key, we're going to use both the outer key and the inner nested key. So first, the outer key, string interpolation. Now, for the inner nested key, we need to follow a particular format where it is enclosed in a set of square braces like this to show that it's in a dictionary. And so in here, we'll say nested key. We can then add the result of calling query components on this inner dictionary to the components array. Remember, query components returns an array of this type, and that's what this components type is. So here we'll say components.append contents of nested components. So here, if the value passed into query components in the encode function is a dictionary itself, then we're going to repeat the process, grab the key and value again for each pair inside this nested dictionary, and call query components on that set of values to append it to the array. It seems complicated, but ultimately you'll see that essentially this is recursion, right? This function is calling itself over and over again until we get to a base case where it can return a string, key, and value pair. And we'll do that in just a second. Okay, so we took care of the case of where value is a dictionary. So next, what if the value passed into this function is an array? Again, we'll check to see that if that's the case, using an if-let statement like before, we'll execute a separate set of logic. So we'll say else if let array equal value as an array of any. And then like the dictionary, we're going to iterate over the values inside the array and call query components on each value. So for value in array. Now in the dictionary case, we passed a key to the inner call of query components. So you can see right here where we use the outer and inner nested key. This informed the server that this parameter should be reconstructed as a dictionary on the server side when processing the request. Now we need to do something similar for the array, but this time there's no nested key in here, just a series of values. So what we can do is we'll copy this, so let nested components. So it's almost the same here, except instead of passing a nested key, we'll leave these square braces empty and just use the outer key. So when this query goes to the server side, it sees this empty array or these empty square braces and knows, okay, this query component needs to be reconstructed as an array of values when making the request. So just like before, we'll copy this line because we're going to append the components, the nested components to our outer array. And that should be it for the array case, which leaves our final else case, where we've now reached the point where the key and value are just single objects and not collections. So we'll say else. Here, we're simply going to get the string values of the key and the value and %encode them. So we'll say let encoded key equal key dot adding %encoding and let encoded value equal, and we'll use string interpolation to get a description of the string and then call adding %encoding. Our array expects a tuple, so we need to combine these values into a 2-element tuple. So we'll say let component equal encoded key, comma, encoded value. And then we can append it to the components array. And finally, at the very bottom, we'll return components. Let's take a step back. From encode, we iterate over our dictionary of parameter values and pass each key and value pair into the query components with function. The logic that query components executes depends on what kind of value is passed in over here. We have 3 possible cases: a dictionary, an array, or just a plain value. With both the dictionary and the array, we simply iterate over the collection and unpack it, again passing each nested value to query components again, so the function is calling itself. Now at some point, even these nested dictionaries and arrays will ultimately contain simple values. So we're going to keep unpacking it until we reach a primitive type, like a string or an int or a double. We then reach this else case. So even when in here, this nested dictionary calls query components, if the key and value pair here is an integer, then when we come into this function again, we're going to hit the else case, and we'll just encode the key and the value using that function that we wrote. We add this to our components array, so now components contains all the key value pairs that we need, encoded, and we return this. So let's test this out. At the very bottom, we'll define a set of parameters. We'll say let parameters. We'll start simple. We'll say that the key is foo, and the value is a Boolean like true. Okay, so using this parameter, we want to encode this, and we want to ultimately end up with a single string that has foo equal true, because that's how we pass URLs. So we'll say encode parameters in URL with this parameters object. And you'll see that we get back exactly what we need. This is the correct format. So let's add something else in here. Let's see what multiple parameters in the dictionary look like and whether our function works. So we'll say let parameters, we'll say foo, the key is bar, which is another string, and then we'll just put random stuff in here. And perfect. You'll notice that the string is formatted as key equal value, and then an ampersand, and then the next key value pair. And you'll also see that it is sorted by keys. For the next example, let's throw in some reserved characters. So instead of bar as the value, we'll say open angle bracket, close, test, 1, 2, 3. And for this value, we'll say #2 or #2. Great, this works as well, as you can see here once it's done running. Look at that. The reserved characters are escaped using the %encoded representation. Let's test this out on 2 more cases. Let's say that for our key foo, the value is a dictionary itself, and in here we'll have another key bar and a value of 1 as the value. So here, since we have a nested dictionary, this means we're going to hit our inner dictionary logic. Notice the key here in the encoded string. So the value is 1 to represent this inner nested value. And over here, we're supposed to get back foo, and then in a set of square braces, bar, as a single key to represent this inner nested dictionary. But since the square braces are reserved keywords in a query, our logic has percent encoded them. So here we have foo, the outer key. Then this represents, oops, let me get rid of that. That's an error. This %5b represents the opening square bracket. Then we have the inner key and then the closing square bracket. So that works. For a final case, let's check if the value is a nested array. So I'll pass the values in. Or actually, this is a Boolean value. There we go. So this is a nested array with 3 cases. And notice the resulting encoded string. This is a flattened version of the string where each value in the array is made into a separate key value pair with foo as the key. So we say foo over here, and A is the key, foo again, and 1 is the key, and then foo and true. You'll notice that each of them are separated by ampersands, and then what's supposed to be a set of empty braces to indicate a nested array is been percent encoded. Okay, awesome. Now we know what a URL with query parameters looks like, and we know how to encode those parameters. We know what encoding means. So let's circle back to the task at hand, and that's defining a URL request.